My name is Rona Segev, and I'm general partner of TLV Partners. Just in a word, what is TLV Partners? TLV Partners is one of the leading VCs here in Israel in the seed stage. And what makes us unique is actually our appetite for risk. We call ourselves high risk, high reward type of fund. We really like to invest in entrepreneurs that are thinking out of the box, that are trying to do new things. Just about our history, we're a new fund here in Israel. We started 8 years ago. It's considered to be a new fund. We raised 7 funds until today, over $1 billion. Our last fund that we invest now from is $250 million. And we invested in over 70 companies, seed companies. And it's quite amazing to see that they are now worth north of $20 billion. Just a very, very short sample of the companies. I'll talk more about our companies throughout the presentation, so you'll have a chance to kind of hear more about our portfolio companies. But let's start. And I was asked here to come today and tell you about the future, predict the future, which is really, really foolish thing to do. And to agree to do. And it's even more foolish to agree to do it on AI because AI is moving so quickly. But unfortunately, this is what I do on a daily basis. I'm a VC, I invest at seed stage. I'm looking for companies that will have something new to offer to the world in a year and a half, 2 years from now. So I have to constantly kind of envision the future. So what I'm going to do here in the next 30 minutes, more or less, is first of all, I'm going to do a very, very short overview on the AI market today, then discuss some of the challenges in AI development, and offer maybe some new ways kind of to overcome them. And lastly, I'm going to present our vision. What is our vision for AI development in the future? And I'm going to show you some of the investments and discuss how they are kind of combining and how they are part of our vision. Can just people see it? Thanks. Okay. But before that, I want to start with something that for some reason people are hesitant to talk about. We invested AI on neural networks 70, 60 years ago with the intention to simulate the human brain. And we started kind of to explore the area. And for many years, it was more or less of a disappointment. But then suddenly, when we kind of fed it with enough data and enough compute, it became something amazing. It kind of became alive. But one of the things that we are not telling ourselves enough, and people are not sharing, is that we really don't understand why and how those neural networks work. And they keep up surprising AI researchers constantly. And when you hear warnings about AI, it's mostly because of that, because we are playing with a very, very dangerous technology that we don't fully understand. And I want you to remember that throughout the presentation because we'll get back to that again and again. But in 2022, when ChatGPT 3.5 was released to the market, it definitely created a huge hype. Everyone got really excited. People started to adopt it. It's, by the way, the fastest technology that was ever adopted. It was adopted faster than mobile phone, faster than TikTok. Like everyone kind of wanted to try it and to play with it. We felt it in our portfolio companies as well. Immediately, we started to see like great growth in demand. And people were also talking about the option or the possibilities that in like 6, 7 years, 10% of all technology spend will be on GenAI. This is kind of unbelievable, okay? The expectations were and are still very, very high. But at the same time, in the beginning of this year, we started to hear kind of a different tone or a different narrative kind of coming into this hype. And this is what I call a GenAI disappointment. Suddenly people were starting to say, well, you know what? It's a toy. It's not really useful. Or you can't really use it. Or it's nice, whatever. And a lot of this criticism was around one feature of LLMs that we are finding it very hard actually to overcome. And this is hallucinations. What does it mean? That the model is moving between just really inventing facts to stating them inaccurately to just saying things that are totally irrelevant. Or if I'll call it in kind of like a more normal term, just make mistakes, a lot of mistakes. And it's becoming very, very hard to use. It's actually very hard to use an LLM to something which is business-like when a large percent or even a small percentage of the answers are mistakes. And there was another problem, because if in 2023 we had the hope that if we'll just increase the parameters of the model and we'll train the model with more data and more accurate data, we can overcome this hallucination problem. Kind of in the middle of 24, it became quite clear to everyone in the field, and I was talking to some of the Llama AI researchers who told me that very, very clearly, is that there is no point in increasing the number of parameters anymore. And they already trained the model on almost all the available data online. So where do we go from here? How do we improve the models if we already exhausted kind of our best chance of, or what we thought was the best chance of improving hallucinations? It's such a big problem, hallucinations, that 3 months ago there was a group of AI research that conducted a new research. The main university that was leading it is Cornell University. They invented this new benchmark to check hallucinations. They call it the wild hallucination benchmark. What you see here is actually the accuracy level of different answers of different LLMs when they're giving long answer and they're stating a lot of facts. What is the percentage of the fact that they're actually stating accurately? And you can see that the best models are only correct 35% of the time, and the other models it can be even 15%. This research shocked the industry, okay? This is like really, really bad. So what does it mean? Does it mean that we hit a wall? Does it mean that GenAI is just a nice game, a nice toy, but nothing more? Well, I think the short answer is, of course not. GenAI is an amazing technology. And I think it's a good moment to remember what Bill Gates said. He said that we have a tendency to overestimate technologies for the short term and to underestimate them for the long term. And when we are getting disappointed, we're actually getting disappointed from our own expectations, hyped expectations. But what we need to remember is that technologies are not always progressing in a linear line. There could be different twists and turns. And sometimes when you hit a wall in terms of advancing in technology, it seems that you're facing a very hard problem. Maybe it's the best way is just to take a step back and try to look at the problem from a different angle. So I want to go back to hallucinations. Now, if you Google search hallucinations, you see that there is a consensus around the world that hallucinations are bad. It's bad, it's something wrong with the LLMs, and we need to fix it. And there is a lot of research trying to figure out why it's wrong and how can we fix it. But around a year and a half ago, there was a group of researchers coming from China, actually, that came out with a very, very different concept. What they said is that hallucinations are not bad, they're not good. Hallucinations are just part of the model. And hallucinations are the exact same process that also leads to what we call LLM's creativity, to the ability of those models to actually create new things, to write new paragraph, to write a poem, to do amazing things. They continue to say that if you will look actually at the human brain, and this is the moment when I want to remind you that we developed this technology in order to simulate the human brain, and we have no clue how it's working, okay? But when you look at the human brain that we were trying to imitate, you can actually see very clearly, and just look at your neighbor, that it's a wonderful machine, but it's far from being perfect, okay? And we suffer from a lot of hallucinations. So we tend to forget, we tend to make mistakes, we kind of remember things inaccurately, we close gaps in our memory. So we do a lot of things that would be considered hallucinations. We're also very, very creative, and we can do a lot of amazing, at least some of us, and do quite of amazing things with our brains. And those researchers said that what really differentiates between creativity and hallucinations is the ability to meet the requirement of the task. And I want to kind of emphasize a minute. So what does it mean to meet the requirement of a task? It means that the answer should be both relevant and accurate. So for example, if you ask me how much is 2 plus 2 and I'll tell you 5, well, it is relevant, but it's not accurate. But if my answer will be a cat is a mammal, well, it's definitely not relevant, but it is accurate. So we want both of those conditions to be met. But is it possible that sometimes an answer that seems incorrect is actually correct, and sometimes an answer that seems irrelevant is actually very relevant? And when you look actually at the kind of the inventions that the humans invented in the last few thousand years, what they claim is that you can actually put them in two categories. One category are inventions that didn't consider to be a fact when they kind of been invented or discovered. And another is that they just happened by mistake. So when Copernicus discovered that the Earth is not the center of the universe, it was considered a lie. Not only a lie, but a foolish, dangerous lie. And it was considered a lie for 200 years until it became fact. And when Fleming left his lab and went for vacation and left the lab dirty, okay, trust me, the last thing that he thought was that when he'll come back, he'll make one of the most important discoveries that probably saved all of our lives here at least once. And there's so many stories about things that were discovered by accident. Just share with you one, Post-it. The scientist who was actually invented Post-it was trying to develop a super glue, like the strongest glue ever. He actually created the weakest glue ever, and he was ridiculed and laughed at by all his peers for years until he started to use it on his own computer, and it became a huge hit. Chips. The story here that there was a chef in Manhattan, and one of the customers sent back the fried chips. He said that they were not crisp enough. He got so frustrated, he went to do this tantrum. So he sliced the potatoes really, really thin, and he fried them to death, and he served them to the customer. You wanted crisps? Here, take crisps. And of course, it changed the world forever and contributed a lot to obesity and heart attacks. What a great invention. But a lot of the inventions actually happened by mistakes. And if you think it makes sense, if we just follow what is correct, if we just follow what we should do, if we never make mistakes, how can we break the boundaries of knowledge, of the knowledge that we kind of know right now? We have to try new things. This is part of the claim that hallucinations and mistakes are actually essential for creating new innovation. Now, I want to end this part with telling you a nice story about Kasparov. I don't know if you know this story, but the first time that a computer won over a chess master was when the Deep Blue won over Kasparov, and they played 6 games. The first game Kasparov won, and the other 5 the computer won. And the story goes is that in move 44 of the first game, the computer did something really weird, a move that no one could understand, and Kasparov freaked out. Some people think that Kasparov thought it was a super intelligent being that is far more intelligent than him. Kasparov claimed that he thought there was this genius sitting behind the computer, whispering to the computer, whatever. Okay, Kasparov freaked out. He lost the other 5 games. Deep Blue engineers afterwards said that it was just a bug. The computer just didn't know what to do. It just defaulted to a random move. If you think about it, did the computer fulfill the task? Was it hallucination or a brilliant move? It really depends what you define as the task. If the task was to do the best move on move 44, he definitely failed. But if the task was to win the tournament, he definitely got to a winning strategy. This kind of concept that mistakes, hallucinations are part of creativity, are an important part, surprisingly got the support also of Sam Altman that a year ago already said that people don't realize, but actually a lot of the value coming from GenAI is because they can hallucinate. But what does it mean? Does it mean that from now on we should just sit here and just say, well, it's so important that they will hallucinate, so we should endure the fact that half of the answers is wrong? Well, of course not. But I want you to think about it in a different way. You know, when we're looking at humans, we are not expecting humans to be both creative and also never to make mistakes, and also to dance very beautifully, but also to do math kind of without even thinking. Kind of like, we do understand that different people and different minds can be different. Why are we chasing so hard kind of the concept that an AI model should be perfect? Why an AI model should be both able to hallucinate and to create, but also never make a mistake? Why not we just separate it? You know, when we are looking for, we are dealing with a very, very tough problem and we want to deal with it, we will usually bring a team. We will bring the team of the best people available. We'll bring some people that are extremely creative and we'll tell them, listen, just go wild. Don't think about kind of consequences, can we do it or not? And then we'll take another group who will actually check the validity. And we'll take someone else and we'll make sure that they're on track, right? We'll build a team. Can we actually build a team of AI agents? Can we have one AI agent that hallucinates freely, another AI agent that do verification, another AI agent that really specializes in one domain? Maybe that's a better way to think about AI agent and not try to make one AI agent kind of perfect. As I was creating this presentation, Strawberry came out. I don't know if you know Strawberry. Who heard played with Strawberry? Can you raise your hand? Okay, not a lot. I don't know a lot about Strawberry. I don't think anyone knows a lot about Strawberry. But I can tell you two things about Strawberry. First, it still hallucinates, even when it's trying to count R in Strawberry, which, by the way, Strawberry is an inside joke, because a lot of the criticism about ChatGPT 4.0 was that it cannot count R in Strawberry. And second is that there is a concept there called chain of thought, which is hidden from users. I assume, but we will see, that there is a lot of hallucinations going on there, but no one cares. Because those hallucinations are just options to solve a problem. At the end of the day, if there is a verification and the models give you the right answer, this is just the process of actually creating, thinking about different options. Okay, so we talked a lot. And now all of that leads us, to AI agents. So we talked about kind of different models working together, and now it's getting to AI agent or multi-system or multi-AI agent systems. What is an AI agent? Is a software package sitting on top of the LLM, adding more capabilities, memory, short-term memory, long-term memory, planning, using different tools. And the really cool thing is that the output could be many things, but it could also be code. And we now have AI agent can create code and actually use Python, can create Python code and create all the Python libraries, which is really, really cool. And of course, I think the holy grail is to have multi-agents. So again, one agent which is kind of running freely, other agents maybe do verification, another agent coding. So I've combined different agents with different capabilities to do tasks together, and actually we are seeing more and more research that is suggesting that combining different agents together is creating way, way better output than just trying to kind of use one agent and to do everything. But how does it all connect to your life? To the software development lifecycle? Well, if you want to understand that, I want to take you just a step back to a year and a half ago. And kind of, this is one of the diagrams of software development cycle. It was consistently mostly from people and automation tools, right? But what happened in the last year and a half is we started to have agents that were starting to help us do different tasks. It was still very siloed. So each of those agents is working in a silo, and each of those agents is really helping developers in a specific domain. But the most popular agent, I think there is no doubt about it, is agents or the co-pilot of GitHub or any agent that is helping developers. Developers were the first one to really adopt those agents with a lot of enthusiasm, and many of them kind of report that they're seeing really enormous growth in how much code that they can write, and the speed and the quality and the quantity. And I thought that this diagram was quite unbelievable. Kind of, it shows how much kind of the growth in commits and repositories where the developers are using Copilot, and you can see that they're just committing way, way more, okay? So everything is happening so much faster. There is a huge debate online, you probably heard about it, whether kind of this speed came in expense of quality. And I don't want to get into it, because I don't think it's important, actually. I think the reality is that everyone is using it, and more developers are using it. And the reality is that we're just creating more and more code. And we need to deal with that, okay? Whether it's good code or bad code, it doesn't matter. Because anyway, we need to do code review, okay? And think about it, we already have, code review is already like a big burden in companies. And usually it's by the more experienced developers that are doing code review. Do we really want them to do constantly code review for AI agent? I'm not sure. We need to write documentation. We need to write testing for all of those things. Okay, just a minute. We need to write testing. You cannot deploy something that AI wrote without testing, right? And think about the poor security teams. Already they are overwhelmed with the amount of scans and vulnerabilities and begging you guys and the developers to put the patches, right? Okay, now just the volumes are growing. And if we think about what can happen in the future when those AI agents will not just be prompted by users, but actually maybe be prompted by each other, we're creating such a fast and such a vast amount and huge amount of code and things that are happening that we just will not be able to have humans in the loop. We'll have to take humans in the loop to leave them to some kind of monitors on top, but actually to bring more and more AI agent to help us kind of stream the process and make sure that we actually keep the quality and integrity of our systems. And now I want to take you to another step, and this is some companies that we invested in the last year. And we invested in a company called Unframe, which is basically when you prompt it, it can write backend and frontend code application to you and deploy it. It's quite unbelievable, actually, really, right? You kind of a UI and you can play with it and you can do stuff. We invested in two companies called Flexer and Dax. When you ask a question and when you ask them to do it, and they just go, they grab data, and they do different things with the data, and then they can kind of like normalize it, they can understand it, they can get to different results and kind of do different actions. So we started to invest in agents and things that are actually doing things in production. And I want you to dream with me something that may happen in a year, maybe in 2, or maybe in 3 years. You know, when I wrote this presentation, I was using Excel, I was using PowerPoint, I was using Photoshop and Chrome. And I was running from one application to another, doing copy-paste, you know. You've probably did it before. Sorry. And I was using probably 1 to 2% of the capabilities of each application. And it kind of, and I thought about it, does it make, maybe like in 2 years from now, I will just come to my computer, there's going to be an AI agent there, and I'll tell the AI agent, listen, I just want kind of a template of presentation, and can you please add a small UI on the side that I can play with colors and text? And then like I said, now I want to add some data, can you just kind of give me some sheets so I can put some data and maybe some UI to play with the graphs? Can you just add some picture now, and then he will go and just create a picture, and so on and so on. And basically, there won't be any application out there. The application will be something that will be built and will disappear once I'm done, okay? And will be built upon my own request. And if you think I'm kind of over-dreaming here, I really encourage you to look at Anthropic new AI agent and play with it, because it's not there yet, but it's definitely going in the same direction, okay? That basically applications are just group of services that are being created for me when I need them and disappear when I don't. And if you can vision this world, and you can believe that it may be possible, so maybe we are actually going through a very interesting transition. 6 years ago, I was here in this conference talking about the move to microservices. I remember because at one point I asked the crowd, how many of you are developing in microservices? And you know how many fingers were raised? Can you guess? One, yeah. It was like, I had this all. But what happened is that we moved from a world that we had very, very clear applications, okay? Actually, it was so clear that we could put them on CD and ship them. And then we broke them into a lot of pieces, and we moved to the microservices world. And guess what? We had to reinvent the whole stack, all the whole tools that were managing those applications. What if we are actually moving to a new stage when the word application doesn't exist anymore? It's now services, only services, that are up and down based on demand. And if you can imagine such a world, let's try to imagine what will be the challenges, the new challenges in managing this world. And this is exactly what got us really, really excited. When we kind of like realized that maybe the world is going to that direction. Maybe we won't have those set tools of application. Maybe things will just be created in front of our eyes, okay? And when we start to think about the different problems, we started also to invest. And I'll take you some of our investments and kind of show you the logic behind them. So we talked about the issue of quality and the issue of testing, okay? No one wants to write testing for an AI generated code, right? You don't want to waste your time. You hate to write tests for yourself, just Node or whatever. So we invested in a company that was called Codium until 2 or 3 weeks ago. It's now called Codo. What they're doing is they're just writing as a human or an AI agent is writing code, they are constantly writing the test, okay, and running them. So you know when they are done that kind of, it meets some standards. We invested in a company called Port. Yeah, so don't listen about how I explain what Port does, okay? Well, Port is basically kind of like a management system that if a developer or an AI agent wants to do something on the infrastructure, he has to go through some process. He has to go through some monitored, managed process. He can't just do whatever they want. This infrastructure is becoming crucial when you have AI agents running around trying to do different things on your infrastructure. Non-human identities is a huge issue. Think about it. We started with, like 15 years ago, we had just human identities. Then we started with microservices, different things. We started to have non-human identities. Non-human identities are just going to grow exponentially over time, but it's not just the non-human identities. It's not just their authentication and their authorization. Their authorization is really connected to the human user who prompts them, right? If I'm prompting an AI agent, maybe the authorization are different than if you are doing it. Okay, so we need to manage this whole matrix, which is rather complex. So we invested in a company called Token, which is doing exactly that. Lastly, we invested in a company called Oligo, which may seem kind of out of context or irrelevant, but it is. Oligo, what it does, it's an application security. Basically, analyze open source, wraps it in a security, and basically doesn't let the open source do anything that it wasn't intended to do. Now think about if we're going to have AI agent creating code and trying to put it in deployment, if we can immediately wrap them with Oligo-like envelope and on the spot disable them to do anything that they were not supposed to do. Okay, so we are actually blocking a lot of possible attacks. But of course, this is just really a little bit of the things, kind of like really just the beginning of things that we need to think about in this new world. That's it. Thank you. I was trying to hallucinate here with you. I hope I was successful in doing so. I truly, truly believe that you cannot innovate, you cannot create anything new if you don't have the courage to hallucinate and to make a lot of mistakes. Thank you.